Hi, I'm Deborah. I'm a data scientist, and in this tutorial, we're going to learn how to build maintainable machine learning pipelines using DVC. First of all, what's the problem we want to address? Machine learning projects can become massive very quickly, but if we structure our code to use DVC pipeline feature, we can end up with a maintainable and reproducible project, and that's what we're looking for, and that's what we are going to do today. First of all, what is DVC? DVC is an open source system that helps us build machine learning projects. It has a lot of features, but today we're gonna focus on this one, the machine learning experiment management. It's basically a command line tool, so we're gonna use the command line a lot on this tutorial. So okay, let's get started. Let's first see how to install Dvc. We're gonna install it as a Python library, and to follow along, you need to have Python 3, pip, and git on your environment. So let's get started. First, let's create a virtual environment for our project. I have an empty folder here that I created for the project. Let's first create the virtual environment using venv, and let's activate the virtual environment. Being activate. Okay, now we are ready. Let's first start Git because DVC works best with Git. Okay, and now let's install Dvc with pip install Dvc. Okay, now we are ready to start the Dvc project, and this is our first Dvc command, Dvc init, and we are done. Now we have Dvc in our project, and we can start using Dvc. Okay, now that we have Dvc ready, let's see what we are going to build. We're going to build a model to classify the 20 news groups datasets from scikit-learn. This is the main script in one single Python script. And what we are doing here, we are getting the data, the training in the test data, and we are using TF-IDF vectorizer to transform the features. And then we train the model. Everything here is using scikit-learn. And then we compute three metrics, the precision, recall, and the AUC scores. And this is basically the project. We can see that we can break down this script in those four famous machine learning steps, like gather data, generate the features, train the model, and evaluate the model. I'm not a native English speaker, as you may have guessed. So okay, how do we turn this script in a maintainable project? Use Dvc. We first we're gonna write a Python script for each of these steps. Then we're gonna save the parameters in a file. Why? Because if we want to reproduce it later, we need to specify what we want to reproduce, and then we save these parameters. And we also need to specify the files each script depends on, and the files each script generates, because Dvc will use this to analyze if it needs to run a step a step or not based on changes on the project. So we're gonna learn how to do all of this using the DVC command line too. So let's create our first step, which is the gather data step. What we are going to do is we are going to use scikit-learn method to load the data and then save it to a CSV file. And that's basically what we are doing in this script, which we're gonna name prepare.py. So when we load the data using the scikit-learn method, we can specify the categories we want to download, and we're gonna use these categories as our first parameter for the project, because as the project goes, maybe we need to change which categories we are using. So we're gonna use the categories as our first parameter. And how do we do it using DVC? We're gonna save the parameters in a params.yaml file. And first we need to say the name of the stage. In this case, we're gonna name this first stage as prepare. And then we need to say the name of the parameter, which will be categories. And then we list the categories we want to download. In this case, computer science and SciSpace. So let's go ahead and create the file. Patterns.yam. I'll just paste the code here. Okay, we are done. And this prepare.py script saves the data inside the data/prepared folder. That's basically what's going on here. And it saves it as CSV files. And just keep things organized, we are going to create a src folder for the scripts. So let's go ahead and do it. And we're gonna create the prepare.py file there. I'll just copy and paste it. Okay, perfect. So now we have the parameters file, we have the script file, and now we need to create this stage using the DVC tool. Going back to that recipe to create the steps, we have a Python script, we have the parameters, the categories inside params.yaml. To run this script, we're gonna need the script, the prepare.py, and this script will generate a folder named data prepared. And this is the recipe we are going to use to create this step using DVC. And to do that, we're gonna use this command, dvc run. When we create the stage, it also runs the stage. So first we need to install the libraries that this script uses. So let's do it. Now to create the stage, we're gonna use our second DVC command, which is dvc run, that we are going to use to build the stage using DVC. These are the main options. We need to specify the name of the stage, the parameters, the file the stage depends on, and the file the stage creates. And this is the main command, like dvc run, and the name of the stage. The categories, we need to specify the name of the stage and then the name of the parameter. The file the stage depends on, the file the stage generates, in this case is a folder, and then the actual command to run the stage, which will be Python 3, and then we point to the prepare stage. Let's just copy this command, and right now we are on the source folder, but we need to run it on the root. And okay, Dvc is running this stage. Let's see how's the folder now. You can see now that we have a dvc.log file, a dvc.yaml file, the data folder, and yeah, let's see what's inside the data folder. Prepared. Yes, we have the test and the train CSV files. Let's take a look at the dvc.yaml. Oops. We have the stages, and we have our first stage prepare, the command to run it, the files it depends on, the parameters, and the output. Cool. And we also have the dvc.log, which has more. This is only for DVC use. Here we have the hash for this prepare.py file. So when we change something, DVC knows that we changed something, and also the parameters we used, computer science, sci-fi, and also the hash for the outputs, so DVC can keep track of the changes. Okay, cool. Now we can visualize the pipeline. This is our third DVC command, dvc dag. Let's run it. Dvc dag. And we can visualize the pipeline. Right now we only have the one step, so there we go, the prepare step. So DVC makes our project reproducible, and to do that we can use this other DVC command, Dvc Repro, where it reproduces the pipeline stages. Let's first run it like we didn't change anything. Let's see what, oops, Dvc Repro. And Dvc saw that nothing changed in the prepare stage, so it didn't run. Okay, what happens if we change something? Let's change this category. It was sci-fi space. Now let's change it to sports, and then let's run Dvc Repro. It saw that something changed, and it ran the script again. So yeah, so far we saw four DVC commands. Dvc init to start the project, Dvc run to create the stage of the pipeline, Dvc dag to visualize the pipeline, and Dvc Repro to reproduce the pipeline. We can also specify I want to reproduce only this step and things like that, but we are keeping things simple here. So yeah, let's now go to the second step. Now let's create the other two steps. First, the second step, the generate feature step. It's basically the same. We're gonna create the file, the script. We're gonna call it featurize.py. We don't need parameters in this stage. This stage depends on the featurize script, and it generates the folder data/features, which will have the features, but after the TF-IDF vectorizer. So let's go ahead and do it. Let's first create the featurize.py file. We just paste the code here. And let's create the stage using Dvc. The name of this stage will be featurize. It depends on the featurize script. It creates a data/prepared folder. Oh, it depends on the data prepared folder because we need to read the CSV files to generate the TF-IDF matrix. And it generates this data/features folder. And this is the actual command to run the stage. Python tree, the script we want to run, the folder which has the CSV files, and the folder we are going to use to save the matrix. Okay, let's run this stage. And we are done. Let's now create the second stage, which is the train the model step. Here we're gonna use the train.py script. Now we have a parameter. We're gonna use the alpha parameter to tune the model. This stage uses the train.py and the features folder so it can load the matrix of the transformed features, and it generates a model.pkl file, which is the model. Okay, we have a new parameter, so let's add it to the file. Okay, oops. The caps lock. So. Okay, and now let's create the train script. Just paste it there. And finally, create the stage using Dvc. The name of the stage will be train. Now we have a parameter, train.alpha. It needs the train script and the features folder. It generates the model file, and this is the actual command to run the script. Let's go ahead and create this stage. Cool. Now let's go to the final step, which is the evaluate the model step. Now we are going to know two new Dvc options, Dvc run options, which are metrics and plots. With metrics, we can specify the file which will save the metrics, And plots, we specify the file that will save the plots. But with plots, we have like the data to actually plot something, and the metrics file is just the actual number of the score. So for the metric, we are going to use the area under the curve, and for the plots, we are going to use the precision we call pairs from generated by scikit-learn. And to do that, in this what's the name? Evaluate.py script, we are compute these metrics and save it to scores.json and plots.json. So let's go ahead and create this evaluate script. Just paste the code there. Nice. And we are in this tutorial, we are only use the Dvc pipeline features and experiment management. But with Dvc, we can also use Dvc to track files. And so with metrics, we have two options. We can let Dvc track the metrics, or we can track the metrics by ourselves using Git. Since here we didn't see how to how to use Dvc to track files, let's stick with the second option and use Git to track our files. And to do that, when we create the stage using Dvc run, we are going to use this option, metrics no cache and plots no cache. So this is our recipe, the script, evaluate.py, that we created already. We don't need any parameters. The files the script depends on, in this case, the stage depends on, in this case, the script, the model, and the features, because we need the test features to evaluate it. And now we have two new options, the metrics and the plots options. And this is the final command. The name of the stage is evaluate. We need the evaluate script, the model file, and the features folder. We are saving the metrics in this scores.json file, and the plots in this plots.json file. And this is the actual command to run this script. So let's go ahead and run it. And we are done. With Dvc, we can build the pipelines, but also manage the experiments. And this is what we're going to learn now. We are going to learn two new Dvc commands, Dvc metrics and Dvc plots. Let's start with Dvc metrics. It basically shows the metrics we are using. Let's go ahead and call Dvc metrics show. We are using the AUC score, and here we can see the actual score. And right now we are using these parameters, these two categories, and this parameter for the alpha value. We also can use Dvc metrics diff to see the difference between previous commit. So to do that, let's first commit something, because we can use a commit per experiment. So let's create our first commit. With alpha equals 0.1. Now let's change the alpha parameter to 9 and save. And since we changed something, let's reproduce the pipeline again using Dvc Repro. So we didn't change the date, the first step, neither the second step, but train changed it, so it ran it again. And okay, now we can compare this configuration with the previous configuration using Dvc metrics this diff. We can also see how the parameters changed between commits. So let's with Dvc params. We can see that it was 0.1, now it's 0.9. And we can also see how the metrics changed using Dvc metrics diff. We can see that it changed just a little bit, but it's already overfitting, so okay. We can also generate plots using Dvc, and to do that we use the Dvc plot command. It's pretty simple. Here we have the command Dvc plot show, then we specify what we want to see on the axis, and then we say the name of the file which has the plot data. Let's go ahead and run it. It creates a .html file, and yeah, here we can see the plot. This was a quick tour. Like, we have for each of these commands we have many more options. You can check on the Dvc documentation, but that's it. The main idea is to create single Python scripts for each of the pipeline steps, then save the parameters in a YAML file, because if you want to reproduce and go back to another stage, we can use this, and specify the files each script generates and each script depends on, because Dvc needs to know this to see if he needs to run a step again, if he needs to run a stage again or not. And yeah, that's it. Thanks for watching.